Welcome to this video lecture. Lecture number 1. Lecture topic Introduction to Mechatronics, presented by Dr. C. Manivel, Assistant Professor, Mechanical Engineering. In this lecture, we are going to discuss about Introduction to Mechatronics System, elements of mechatronic systems, components of mechatronic system, concept and applications of mechatronic systems. Introduction to Mechatronic System. The word mechatronics was originated from Yasakawa Electronic Company from Japan in 1969. It's spread throughout the Europe and is now commonly used in global. The word mechatronics is composed of mecha from mechanism and the tronics from electronics. Moreover, mechatronics solve technological problems using interdisciplinary knowledge consisting of mechanical engineering, electronics, and computer technology. In 1996, Karashima, Tumisuka, and Fukuda defined mechatronics as being the synergetic integration of mechanical engineering with electronics and intelligent computer control in the design and manufacturing of industrial product and process. The Polden defined that the definition for mechatronics engineering, a mechatronic system is not a just marriage of electrical and mechanical system and is more than just a control system. The mechatronic system is a complete integration of them all. Based on the above definitions, finally we can define as the definition for mechatronics is the field of study concerned with the design, selection, analysis, and control of system that combined mechanical element with electronic components. Moreover, we can define as working definition for mechatronics is the synergetic integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithm, and computer hardware and software to manage complexity, uncertainty, and communications in the engineering systems. The graphical images depict that based on the definition of mechatronics is the combination of information system with the computer system for mechanical system and electrical systems. The more understanding of the definition of mechatronics is mechanical with the CAD, integrate with computers and digital control systems will make mechatronics. Sometimes control electronics and control system will make interface with digital control systems of mechatronic systems. Another words we can call it as electromechanical systems interface with electronic system and control electronics, also call it as a mechatronic systems. Sometimes mechanical CAD creates a design, the system will make as a mechanical system with the electromechanics concept will create a mechatronic systems. Furtherly, we can classify it as various applications of mechatronics as automotive system, aerospace, medical industry, medical testing, defense systems, consumer products, manufacturing systems, materials and material processing are some of the identified applications area for the mechatronics. Evaluation of mechatronics. The technological advances in design, manufacturing, and the operation products or the device can be traced through the engineered examinations of various classifications like industrial revolution, semiconductor revolution, and information revolution. Let us discuss one by one now. First we will discuss about industrial revolutions. Here the design of products and process for energy conversion and transmissions. This will allowing the use of energy to do useful works. Engineering design of this era were largely as mechanical. Example, the operation of motion transmission, sensing, actuation and computations were performed using a mechanical component such as cam, gear, lever and linkages mechanisms. Purely mechanical systems suffered from power amplification inability to any one of the systems, like energy losses due to tolerance, inertia and frictions. This will overcome through the technology applications of mechatronic systems. Here some of the examples of purely designed mechanical components shown here. Float valve systems as mechanical system. This will updated by automatic control system of mechatronics. Watts governor will used mostly in automotive industry to control the vehicle speeds as well as cam operated switches. This will replaced by electrical switch or the electronic control devices from the mechanical devices. Bimetallic strip or thermostat element will be used to measure the temperature or the control the temperature in a mechanical systems. It will be replaced as a mechatronic systems later on. Semiconductor revolutions. The creation of integration circuit technology, that is nothing but a IC technology in this era. The effective miniaturized power electronics could amplify and deliver needed amount of power to actuators. The signal conditioning electronics could filter and encode sensory data in analog or the digital format. The hardwired onboard discrete analog or digital integrated chips provided computational and decision making circuits for control of mechanical devices. Information revolution. The development of VLSI technology led to the introduction of microcomputer or the microcontroller or sometimes in microprocessor. Now the computing hardware is everywhere, cheap and small components. As computing hardware can be effortless interfaced with real world electromechanical system. It is now routinely embedded in engineered product process for decision making. Microcontrollers are replacing precision mechanical components like precision machined camcraft that in many applications functions as a timing devices. Programmability of microcontroller is providing a versatile and flexible alternative to the hardware, analog or the digital computational hardware. The integrated computer electrical mechanical devices are now capable of converting, transmitting and processing both the physical energy and the virtual energy. It is nothing but the information systems. The consolidated result of this information revolutions era is highly efficient products and processes are now being developed by judicious selections and integration of sensors, actuators, signal conditioning, power electronics, decision and control algorithm, and computer hardware and softwares. Mechatronics has evolved through the various stages that is named as primary level, secondary level, tertiary level, quaternary level of mechatronics. Primary level mechatronics, it integrates electrical signaling with the mechanical action at the basic controls level. For example, fluid valve and relay switches used in this primary level of mechanical systems. Secondary level mechatronics, it integrates microelectronics into electrically controlled device. For example, as cassette tape player is the example for the secondary level mechatronic systems. Tertiary level mechatronics incorporates advanced control strategy using microelectronics, microprocessors, and other application specific integrated circuits. For example, microprocessor based electrical motor used for actuation purpose in robotics and robo cars, etc. Quaternary level mechatronics attempts to improve smartness a step ahead by introducing intelligence, that is nothing but an artificial neural network and fuzzy logic, and fault detection and isolations capability into the systems. Mechatronics applications. The smart consumer product, examples of home security, camera, micro oven, toaster, dishwasher, laundry wash and dryer, climate control units, automatic digital camera are some of the examples of smart consumer products. Computer disk, VCR, DVD drives, ATM, etc. also latest trends in mechatronics applications category. In medical field, implant device, assisted surgery and haptic device also the example of mechatronic system in medical fields. In defense, unmanned air, ground and underwater vehicle, smart weapons, jet engines are some of the examples in the defense field of mechatronics. In manufacturing sectors, NC and CNC machine tools are the examples. Moreover, the rapid prototyping and robotics also the same category of mechatronics applications in manufacturing sectors. Automotive, climate control, anti-lock braking system, active suspensions, cruise control, airbag system, engine management system, safety and security systems are some of the examples of automotive field of the mechatronic systems. Network centric distributed systems, distributed robotics, telerobotics, intelligent highways are some of the examples of mechatronics applications used in the network centric and distributed systems applications. Here the pictures depict that the examples of robot as well as robot sensors used in the mechatronic systems. Another example, it is the indirect involvement of mechatronic systems. it is nothing but a motion and force control of an indirect drive robot used for some applications is shown here. Another example of mechatronic system is to track straight line or identifying the obstacles to avoid the collisions or the line follower robots are the some of the examples of mechatronic system that is shown here. Another example is the mechatronic systems. Here the computer disk drive is the examples of a rotary mechatronic systems. The basic requirement of this system is to provide accurate positioning of the magnetic read head, and it provides precision control of media speed, also the extraction of digital data from the magnetic media. These are the major objectives and fulfillment of mechatronic systems which were used in a computer disk drive after implementing the mechatronics concept. Another example of the mechatronic system is washing machine. Here in our day-to-day life which we are using as domestic application, this system requirement is to understanding of load size, receptacle to hold cloths, plumbings, agitation of drum, easy usage, reliability, low cost. These are the advantages which we are using in washing machines based on mechatronics applications in our day-to-day lives. Here some of the actuators are used to mechatronics implementations, that is AC or DC motors, water inlet and drain applications purpose we are using as drives, as well as sensors we are using to maintain the water level as well as to control the speed or the balance of the washing machine systems. Some of the advantages of mechatronics is cost effectiveness and good quality products can make, high degree of flexibility to modify or the redesign which is suitable for the customer requirements to to bringing out the best product to the marketplaces, very good performance characteristics, wide area of applications which we are implementing mechatronics applications, greater productivity in case of manufacturing organization because of the automations which we are implementing, greater extent of machine utilizations without any losses or the error. Some of the disadvantages of the mechatronic system is high initial cost because of the huge number of components involved in to create a mechatronic system, multidisciplinary engineering background required to design and implementation because of the integration of other engineering departments concepts involved to make a mechatronic systems, need of highly trained workers because of most of the machineries or mechatronic systems are complex as well as it will work based on the programming controls. The final outcome of this lecture is the beginners can understand about the definition of mechatronics, what are the basic elements involved in mechatronics, and what are the basic components involved to make any mechatronic systems, the main advantages and disadvantages of the mechatronic systems. Thank you for your patient listening.